Okay, I want to go over three problems from the previous homework assignment 2-2 because I didn't offer much explanation when I posted the answers. We're going to look at problems 5, 7, and 8. Here's number 5. Look at how I began doing this problem. I believe I've said to you at least once already that a lot of students will look at a problem like this, not know what to do, call me over and say, Mr. Nortillo, I don't know what to do. Okay, well, here's what I did first. I drew a picture. And to a lot of students, this is not what they want to hear from me. When they say, I don't know what to do, what they want to hear from me is, what do I add? What do I subtract? What do I multiply? What do I divide? But the first most helpful thing to do here is to draw a picture that makes it clear that V is in between U and O, because that's what the problem tells us. V is the midpoint of U and O. Now, if I had to put these points on a graph, they might be going this way, they might be going that way, but it doesn't matter to solve this problem. What matters is I know that V is between U and O. I wrote down the coordinates of U, the coordinates of V, and I made up variables for O. This is the value of algebra. Okay? It teaches you that coming up with variables for things that you don't know is a really useful idea. And then knowing that the midpoint is at the average of the endpoint locations, I just set up an equation that the average of 24 and x, 24 plus x divided by 2, is equal to the x coordinate at the midpoint, negative 24. And some of you may still be getting used to the idea of averaging a number and a variable. You might still be asking your question, how do you do that? Well, you just write down adding those two things together and divided by 2. There, you've just written the average. It's just like in algebra. If I said to you, what is 5 plus x? Before you ever learned any algebra, you would have responded and said, how do I know what 5 plus x is? But you've learned that when a teacher asks you what's 5 plus x, all they're trying to get you to say is 5 plus x. Well, the same thing here. When I'm asking you, what's the average of 24 plus x? I'm just trying to get you to realize it's 24 plus x and divided by 2, and you should write that down because then you can set it equal to the negative 24, and that equation is so easy to solve. Same thing for the y. The average of the two y coordinates, the one we know and the one we don't, should be equal to the y coordinate at the midpoint, and then that equation is so easy to solve. I hope when you run into a problem like this on the quiz that you're going to use this approach. I think it's the easiest approach to use. Let's take a look at problem number 7. Now, I like this approach, this same approach for problem number 7, although I will grant you that since the numbers are kind of small and there are no negatives, that there is another way to solve this problem that's probably just as easy as this way. But once again, I drew a picture and I put point A being the midpoint, in the middle of the other two. And I wrote down the coordinates I was given for all 3 points. And then I just set up equations. Average the M and the 22, and that should be equal to 15. Here's that equation right there. Averaging the M and the 22 comes out to 15. Very easy equation to solve. Averaging the two y coordinates, the n and the m, should come out to be 9. Here's that equation, which I can't solve until I've solved this equation. And then I can plug 8 in for that m and finish it. Very straightforward and easy. Okay. Now, for this problem, again, because the numbers are fairly small and there's no negatives, I think this might be an equally easy way to treat this problem. Again, once you've drawn the picture, first you got to draw the picture. And we really should not have these numbers here yet, that 8 and 10 and that 8, because I haven't found them yet. Okay. But after you've drawn the picture, you might realize, oh, hey, A is in the middle. To get from C to A, those x values are going down by 7, from 22 to 15. From the endpoint to the midpoint, I'm going down 7 units. And so therefore, to get to the other endpoint, I must also have to go down the same amount, 7 units down. 7 units down from 15, that is decreasing from 15 would be 15 minus 7. And you can probably do that in your head. So that's got to be 8. And now we also have a way to get to this n value, because now I can put this 8 over here for this m. And once again, I can go from one endpoint to the midpoint. I got to go up 1 to get from 8 to 9. So to go from 9 to the other endpoint, I must also have to go up 1. 9 plus 1 is 10. Okay. That would be fine if you solve the problem that way. That works. It shows you understand the relationship between a midpoint and its endpoints, and that's what I'm trying to get out of you here. Okay. Finally, number 8. This was a tough problem, much tougher than the one I modeled for you in class in the video. Okay. But I'm going to take the same approach, and I'm going to start by drawing a picture. Hey, Mr. Nortillo, I don't know how to do this problem. Yeah, I know. How about drawing a picture when you don't have a picture? M is the midpoint of AB. So draw a picture that makes A look like, or makes M look like the midpoint of AB. Okay, there it is. And now do this also. Don't just make M look like the midpoint of AB. Put some marks in the picture that make it clear to whoever's reading the picture, which is you're reading the picture. You need to draw a picture that you can make sense out of once you're done with it. Okay? So put these X's in there to show yourself, to keep track of the fact that this segment length AM is equal to that segment length AMB. By the way, I should pause for a minute here to talk about diagrams and how to create them and how to read them properly. I'm erasing a little bit from what I did earlier. Okay, and I want to show you, I'm going to take a short detour from solving this problem to talking about diagrams. Okay, so let's look at this diagram here. I've got a long line segment here, point A, B, C, D, E, and F. Can you take 2 seconds and write down, you got some scratch paper? Grab a pencil, grab a paper, pause this video, write down a name for this segment that goes from A all the way to F. Write down a valid name for that segment. Do it. Pause the video. Okay, here's a valid name for this segment. AF with a segment bar over it. Here's another valid name, FA with a segment bar over it. You must have the segment bars, okay? And you must also have the names of the points at the end of the segment. But here's not a good name, A, B, C, D, E, F. That is a horrible name for a segment. We don't do that in geometry. Never, ever. When you're naming a segment, you only ever use 2 letters in the name, and they must be the letters of the points that are at the very ends of the segment. You don't ever use any of the point names in between. Okay. Now, if I want to name the segment that's running from B to E, okay, and then I could write BE or I could write EB. It doesn't matter which letter comes first and which letter comes last. That makes no difference at all. Absolutely none. Okay? But we never use more than 2 letters in a name. Now, suppose I put an X right here to represent, as a variable to represent the length of something in this diagram. My question to you is, which segment length does this X represent? I mean, is there any way for you to know? Does it represent the whole thing, AF? Does it represent just this, like this closest, shortest one here from D to E? Does it represent the segment length from C to E? Like, is there any way for you to know, or is this just too vague? Well, the answer is we have rules for how we interpret geometric diagrams. You probably are not aware of them, so I just got to tell you. This X, if I see this diagram, to me and anybody else who has learned the rules, this X represents the length from D to E, because this point is the closest thing to X on one side, and this point is the closest thing to that X on the other side. That's how I would interpret it. That's how you have to learn to interpret it. It cannot represent the length from E to C or the whole segment from A to F or anything else. Okay. Now, what if I want to put in another variable, let's say a Y, to represent the length from D, not just to E, but all the way to F? Where would you put it? Would you put it there, like right in the middle of the D and the F? No, that wouldn't work, because that would have to represent the distance from E to F, because E is the closest point on this side and F is the closest point on that side. So it would do no good to put a Y there. Okay, some of you might want to put a Y right there on top of the E and say, there, okay, now D is the closest point on the left and F is the closest point on the right. No, that's no good either, okay? For two reasons. Number one, some of you are just careless or sloppy, and you would try to put a Y on top of the E, but you would put it right there, and then it doesn't really look like it's on top of the E. It looks like it's between the E and the F. So that's bad. But here's another reason why putting a Y on top of the E is no good. Okay? What if I want to put a variable in that represents the distance from the A to the D? Where would you put that variable? Would you put it on top of the C? That would be confusing. Would you put it on top of the B? Oh, that wouldn't be very good. Would you put it somewhere in the middle of A and D, like right there? No, then it would look like it goes from B to C. Here's what I would do. I would make one of these brackets going from A to D and put a Y there. That makes it clear that this variable represents the length from A to D. If I want a variable that represents this whole entire segment from A to F, I draw a great big bracket like that and put, I don't know, some variable M down there, okay? Your brackets do not have to be as pretty as mine, but they need to communicate clearly to you and or whoever is reading the diagram. So now back to the problem. Okay, this X represents the length from A to M, and this X represents the length from M to B. They've got to be the same because M is the midpoint. Let's move on. T is the midpoint of AV. Wait, M is the midpoint of AB. No, I missed this part. V is the midpoint of MB. Okay, I'm going to make V look like the midpoint of MB. Uh-oh, that just confused my picture. I mean, sure, V looks like it's exactly in the middle of M and B, but now this X is confusing. I can't tell what that means anymore. You should never have a variable directly above a point. That's confusing. So I'm going to erase the X, put in a bracket, and move the X up there. Okay. And now if V is the exact midpoint of MB, well then wouldn't this segment here be half of an X, and wouldn't this be half of an X? Sure, they would. Or you could write 0.5X and 0.5X. That would be fine. Or hey, if you hate having to look at fractions, which I don't, and maybe you don't either, how about if we change the variables and just call this a whole Y and that a whole Y, and then change this thing from X to 2Y. I mean, wouldn't that also be accurate? Doesn't this all show that each of these segments is half as long as this one? But then if we're going to change that X to a 2Y, while we're at it, why don't we change that to a 2Y? Right? Because the fewer variables we have in the diagram, the better off we are, the easier it's going to be to solve some problem eventually. Let's continue. T is the midpoint of AV. All right, here's the really difficult part. T is supposed to look like it is exactly halfway between A and V. Well, that looks to me like it would be right about there. Okay, now I've just ruined this 2Y, because now that 2Y looks like it's going from A to T, but it's supposed to go from A to M. So I'm going to erase my 2Y, put another bracket there, and put the 2Y back in. okay? T is supposed to be halfway between the A and the V. So I sure would like to know, I would like to have a variable expression for AT and TV, and they should be the same as each other, whatever they are. Okay, now here's something you just have to see in this picture. And this is oftentimes what geometry requires of you. It requires you to see something and then act on it. And if you don't see what you need to see, you're going to be stuck. For a lot of geometry problems, I can't tell you, oh, do this step, 1, 2, 3, and voila, you will get the answer. The geometry doesn't work that way a lot of the times. You've got to see something. And in this case, what you have to see is that the entire distance from A to V is this 2y and then plus this one more y. From A to V is 2 y's plus another y, or a total of 3y from the A all the way to the V. And since T is exactly halfway in between, from A to T is 1.5y, and from T to V is also 1.5y. And without recognizing that, I think it's going to be really hard to solve this problem. Here's the last piece of information. AB is 60 units long. This whole thing is 60 units long, but now we've given 2y here and 2y there, so the total length of that segment is 4y, and that 4y has to be equal to 60. Therefore, y is 15, and now I can find out how long this segment is. 1.5 times 15 is 22.5, and that's how I got the answer here. That was a tough problem. Congratulations to you if you solved it. Okay, and you may not have solved it the way I did, but however you solved it, I cannot believe that you would have stumbled on that correct answer by accident. You must have done some really good math. Okay. There's another problem like this coming on tonight's homework assignment, but it is easier than this one, I promise you. You still got to draw a good picture. You still got to use some variables, but it is not as challenging as this one. Here's the lesson for today. Tonight's homework assignment has you doing a lot of algebra review, okay? Algebra review that we haven't done yet this year. So for instance, you've got 4 problems that look like this. Graph all the solutions to this equation. Now, probably, if I just left you to your own devices, what the vast majority of you would do, almost everyone, you would decide, I can't graph this until I change it into slope-intercept form. I'm going to have to solve this for y. So you would write minus 9x minus 9x. You'd put a line underneath it. You'd write minus 7y is equal to negative 9x plus 63. You do all this writing. You would divide both sides by negative 7. You'd write y equals negative divided by a negative is a positive. So you'd get 9/7 x, and then a positive divided by a negative is a negative. 63 divided by 7 is 9, so negative 9. Okay, then you'd go, okay, the y-intercept is negative 9. You'd put a point there, and then you'd use the slope to find the next point, and you'd have to count 16 spaces, 9 up and 7 over. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Put a point there. Hopefully you remember that I told you if you just get 2 good points, you've got enough. You would draw a line through those, and finally you'd be done. And I've been trying to communicate to you that this is a long way to do this problem. This is a lot more work than you need to do. Are you interested in an easier, faster way to do this problem? I sure hope so. Okay? I'm going to sort of pretend like I'm making a table of values here. And some of you might think, whoa, Nortillo, that's not easier and faster. Are you kidding me? I mean, that's like really old before we even knew how to do this algebra stuff. This takes forever. I hate this. Trust me. I'm going to choose the point 0 for x. Okay. Now, if you plug in 0 for x, what's 9 times 0? It's 0, right? So it's like that whole term disappears. You have 0 minus 7y is equal to 63. And solving this equation for y is super easy. I mean, really, do you have to write anything down to do this? You're going to divide both sides by -7. 63 divided by -7 is -9. There you go. There's one ordered pair that's part of the line, 0, -9. Go down to -9, put a point. Now, how can I quickly find another ordered pair? Don't choose a value of 1 or 2 or 3 for x, or even -1. That's going to be tough. You're going to get a nasty fractional answer for y. What's the smart thing to do? Do you know what the smart thing is to do? Choose 0 for y. I mean, who says we can't choose a value for y instead of choosing a value for x? We can. So start over and plug 0 in for y. What's 7 times 0? It's 0, right? And what's 9x minus 0? It's just 9x, right? And so now if you're solving 9x equals 63, you're just going to divide both sides by 9, and 63 divided by 9 is 7. So x comes out to be 7. There you go. There's another ordered pair on the line, 7, 0. Go find the 7, put a dot, and we found the same two dots that we did when we did all this algebra to find the y-intercept and then count the slope, but without doing all of that work. Way quicker, way easier. Okay? I strongly encourage you to use this approach for the homework problems tonight. Okay? Get used to doing it this way, because once you get used to it, you will agree, gosh, that's so much faster. It may not seem an easier method to you now because you're not used to it. Okay? You might be resisting right now in your head. You're going, nah, I like this way better. Maybe you like this way better because you understand it, because you've done it so many times this way. But please try this. You'll like it. Okay? And I'm going to show you one more time the same approach for this line here. Okay? Put in 0 for x. And then do it again and put in 0 for y. If I put in 0 for x, 4 times 0 is 0. And then 10y is equal to 30. So y would have to be 3. Man, how fast was that I came up with one ordered pair? And now put in the 0 for the y. 10 times 0 is 0, which makes that disappear. And now 4x is equal to 30. Divide both sides by 4. You might have to reach for your calculator to do that. 30 divided by 4 is 7.5. So let's go to put these 2 points on the grid, 0, 3, and 7.5, 0. And draw a line through those 2 points. That is so much faster than rearranging this equation in a slope-intercept form. Try it, please. Okay? All right. Only a little bit more to talk to you about regarding the homework assignment tonight. Let me find it. Got to put it in my hands here. All right. Page 1 of the homework is just practice with the kinds of problems from 2.1 and 2.2. Okay? And I hope you are learning to do a problem like this and a problem like this, what I would consider to be the easy way. Okay? Setting up equations. I hope you're using the coordinate system method for a problem like this. I think that makes it easy. Certainly a whole lot easier to explain, and I think easy to understand once you become used to that. And here's that problem I was promising you, where you've got to draw a picture and you've got to use some variables, but trust me, it's easier than the one that I just solved for you. Okay? And then page 2, here's these problems where I'm asking you to graph equations, and I hope you're going to do it without rearranging any of these equations into slope-intercept form. I think it'll make your life a lot easier. And then pages 3 and 4 are solving equations. I have not asked you to solve any equations like this yet, so this is more just algebra review. And I would strongly urge you to do all 14 problems, because the nature of the problems keeps changing. You're going to have to keep doing more things that you didn't have to do in the earlier problems. I've got all the work and all the answers shown when I post the answers. Do them all. When we have another algebra quiz, which we have soon, all the old algebra review is going to show up on it, and all of this new stuff also. Good luck on the homework.